In this video, we're going to continue looking at low structures with two more structures here. We have CH4, which is methane, the gas typically used in a lab as a Bunsen burner fuel. And here we have formaldehyde, which is an organic molecule typically or formally used in anatomy classes to preserve specimens. We identify the central atom as carbon, and we have 4 peripheral atoms. We connect everything once. We write our formal charge table. So we have carbon and 4 hydrogens. We assign valence electrons, so we know carbon has 4 valence electrons, hydrogen has 1. So we have 8 valence electrons total. Each line is 2 electrons. I have 4 lines, so I have 8 electrons total, so no need to add dots. Each hydrogen has been assigned 1 line. That's 2 electrons. 50% of 2 is 1. The carbon now has 4 lines. That's 8 electrons. 50% of 8 is 4. Top number minus the bottom number gives you the formal charge. So not only do I know it's a pretty stable molecule, but I know that methane is neutral because the sum of the formal charges is 0. Something like this might be a bit more challenging because it's not immediately apparent which is the central atom. Here it was clear because I had 2 types of atom and one was less abundant. Here I've got a couple of atoms that are equally abundant. But you know that hydrogen can't be central because it only forms 1 bond, and you can't build structure if you can only ever form 1 bond. Oxygen forms 2 bonds. You can build structure with 2 bonds. But carbon can form 4 bonds, so it's much more useful, it's much more likely that carbon is central because it can form more bonds. So if nothing else, that would be a good bet that carbon is central. Now I'm going to surround it with its non-central atoms, and I'm going to connect everything once. I have carbon, hydrogen, hydrogen, oxygen. It doesn't really matter what order you put these in. I know that carbon has 4 valence electrons, hydrogen has 1, oxygen has 6, so I have 12 valence electrons total. Right now I've only accounted for 6 valence electrons, so I need to add an extra 6 valence electrons, and they would preferentially go to the most electronegative element, which is oxygen. So oxygen has 6 dots, plus another 2 here is 8. So I have all 12 electrons. The problem is my carbon only has access to 6 electrons. Carbon won't stick around if it won't achieve the ability to be isoelectronic with a noble gas. So I replace this lone pair with a bonding pair. So I still have my 12 electrons, but now carbon also has access to the valence electrons that it would like to. So once I'm convinced that everything here is isoelectronic with its noble gas, I then go on to assign electrons here. Each hydrogen has 1 line, that's 2 electrons, half of 2 is 1. Carbon has 4 lines, that's 8 electrons, half of which is 4. And oxygen has 2 lines, that's 4 electrons, half of which is 2, plus you've got 4 dots. Top number minus the bottom number is the formal charge. This is a stable structure. It's also a neutral structure.